Hello guys, so welcome back to another video. And so for today's vlog, we will be talking about this ballast control panel. It doesn't have any indications for the ballast, bilge, and for the fuel oil tank. And the most important part is it doesn't have any indications for alarms whether it is high level or low level. Which means this is very critical, especially if the ship is doing bunkering. This is a pending job from the previous electrician, and the history that he gave me, he said that he already changed this power supply.
So here's the catch. That power supply installed in there is just a brand new power supply which was installed by the previous lecky, and this is the old one, and it got troubled again after 2 weeks of installing it. And when I got here, that's the condition already. It doesn't have an output voltage. So this is the old power supply. It has an input of 100 volts and it doesn't have an output voltage. So we need to find a new power supply which we can replace the unit inside. So after checking, we have this replacement of power supply. It's a small one, but the rating is just the same, so we can use this one in replacement of this old one. This is the old one and this is the replacement. The size is like this, but we will manage to install it in replacement to this one.
So the first thing I did is I asked the chief engineer if they are doing internal transfer of fuel, so that it will be very safe for us on our side not to do anything on the ballast or fuel valve control panel. Let's pause for a while and analyze the situation. Why do you think that the new power supply got troubled again after 2 weeks of installation? So the next step that I did is I dropped off the breaker and traced the wiring diagram. So that power supply is this DCU 24 volts. The input voltage is just 100 volts and the output voltage is 24 volts. And after this power supply, it goes to one of the fuses and with the node which included one of the diode. As you can see, the negative side of the power supply is connected to the ground and it is also connected to the output line of the diode. So I focused my investigation on the positive side of the output line, which is after the fuse, because I'm already suspecting that there might be a earth fault or short circuit into the system. But since the other line is connected to the ground, I will just be focusing onto this line after the fuse. So what I did is that I removed the fuse and I will remove also the line after the fuse and measure the line to ground resistance. In this way, I will know if there is an earth fault onto our line. After measuring the lines after the fuse, I'm getting only 70.4 kilo ohms. This confirms why we have a faulty power supply. That is because of this earth fault. But of course, I cannot just install the new power supply without tracing where is this earth fault is coming. Since we have a node on this line, we need to remove the connections and find out where are these two cables are connected. In this way, we will know if or we can trim down the number of lines which is causing this earth fault. And after removing the screws, I found out that the lines are also marked as PA1 and it is not following what is written onto the manual. So what I did is I traced the cable manually and I found out that it is all coming to these both or same connections. Since PA1 are linked together, I have decided to remove them one by one to know which is the line that is causing this earth fault. Until I have found out that the last two lines are the one that is causing the earth fault. I did another tracing and I have found out that in the manual, these PA1 cables are the ones that are going onto the individual valves, which gives an indication to the local control panel whether if the valve is open or closed, which means that they are connected into individual limit switches of each and every valve, this LS limit switch. And it is a common line for every PA1 lines which goes to every valve. This only means that we need to check one by one all of these valves for the ballast, for the bilge, and for the fuel oil tank valve indications. So tracing of this kind of trouble needs patience because we need to trace all these PA1 cables, whether it is for the ballast, for the bilge, or for the fuel oil tank valve. As you can see in this terminal block, all these PA1 are linked together and we need to separate them one by one. The idea is to remove the connections from the output line of the PA1, the line that is going to the valve, and not the blue cables which are coming from our panel side. So as you can see, I'm removing all of these cables and then I will measure them one by one, line to ground, and see which is the one that is causing the earth fault. So it took me around 1 hour before I found out what is the main reason or which cable is causing this earth fault. So the culprit is the one that is connected to the 011 BPW, which is this wire which is giving the 70.4 kilo ohms. So what we are going to do is that we will keep this cable isolated and then we will put back the PA1 cables and we will install the new power supply. I have connected back the fuse and installed the new power supply, but we will not power it on unless we measure again the positive line from line to ground measurement and to ensure if we are having the infinity measurement or the open line. So as you can see, we are having a healthy line. So in this way, we are sure that we are safe to power on again our ballast control panel. After patiently tracing the earth fault, voila, we are now having all the indications into our ballast control panel. To see if it is working properly, I asked the duty officer to go to the local site and see once we press this open or close command if the valve will follow. Okay, opening number 1.
Okay, now it's fully open, right?
Yes, number 1 is fully open now.
Okay, now you close number 1.
Closing number 1.
Okay, I can see.
We have also tested all the alarms for the high level and for the bilge level sensor. You can see this valve here is the one that is isolated. So this is the one that we will be checking and see what is the problem on that valve. Now we have the indications and everything is working fine except for that one valve in question, and we will go to the cargo hold and check if there is a water in there or there is a rust that causing a low insulation.
and we replaced this old one with a new one. And again, I hope you learn from this lesson that whenever you have a problem with the power supply, better to check first the output line if you have a short circuit or at least low insulation, so that you will not fuck up the new power supply. So I hope you learned something from this video. This is your Lucky Jake, and see you.